So guys, till now we have discussed about the different laws of combinations like law of multiple proportion, law of definite proportion, law of conservation of mass. After that, now we are going to discuss about the Gay-Lussac's law. Now, the Gay-Lussac's law. Gay-Lussac's law of combining volume. Gay-Lussac studied about those reactions in which the gaseous reactants and the products were involved, and he said that there is a certain definite relationship between the volume of the reactants and the volume of the products. He stated that when gases react with each other, they do so in such a way that the volume of the reactant and the volume of the product bears a simple whole number ratio. Now what does it mean actually? I am giving you one example, and that is hydrogen is combining with nitrogen to give ammonia. He said that 3 volume of hydrogen will combine with 1 volume of nitrogen to give 2 volumes of ammonia. It means that if we have 3 liters of hydrogen, it will combine with 1 liter of nitrogen and it will give us 2 liters of ammonia. So the relation between reactants and the products will be 3:1:2. So that was Gay-Lussac's law. Let's move on to Dalton's theory. Now, Dalton gave some points about the atom, and those points, the first point was elements are composed about extremely small particles, and those particles are called atoms, and then atoms are indestructible. They cannot be created nor be destroyed, or they are indivisible, you can say. Now, we all know in NCERT there is only Dalton theory is given. I am telling you about the modern atomic theory also, because in modern atomic theory all the drawbacks of Dalton atomic theory was covered, right? So what was the first point? Elements are composed of extremely small particles which are called atoms, and they are indivisible. But the modern atomic theory says that atoms are divisible and they can be divided into electrons, protons and neutrons. Point number 2, all elements will have the identical type of atoms. It means that suppose we have sodium, all sodium atom will have the same shape, size or chemical properties, and everything will be same. If we have carbon, all carbon atoms will be same, but it was incorrect. How? We have different isotopes like carbon 12 and carbon 14. So carbon 12 is also carbon and carbon 14 is also carbon. So these two atoms, that is carbon 12 and carbon 14, are different from each other. Now the third point says that atom of one element is different from atoms of all other elements. That is not always correct. As we know that the mass number of calcium is 40, the mass number of argon is also 40. So there can be some sort of similarities between atom of one element and the other element. The fourth point, he said that compounds are composed of the atoms of more than one elements. That's correct. But he also said that the elements combine in a simple whole number ratio. Now that is not always correct, right? How? Let's take an example of water. Suppose water is, the formula is H2O. So there are 2 hydrogen and 1 oxygen. So the ratio is 2:1. So for this it is correct. But if I take the example of sugar, that is C12H22O11, 12:22:11 is not the simple whole number ratio. It's the whole number ratio, but it's not the simple whole number ratio, right? Now, point number 5. Point number 5 says that atoms cannot be created nor be destroyed. And we all know that in the nuclear reactions, atoms can be created and can be destroyed also, right? So this was Dalton's atomic theory and the modification done by modern atomic theory also. Let's discuss about Berzelius hypothesis. Now, Berzelius hypothesis. What Berzelius said that equal volume of all the gases at same temperature and the pressure conditions will have same number of atoms. Now, this also indicates that atom has their individual existence. Now, what he did, he applied his law on the reaction hydrogen plus chlorine gives hydrochloric acid gas, and it was experimentally proved earlier that one volume of hydrogen will react with one volume of chlorine to give 2 volume of hydrochloric acid gas. So, applying Berzelius hypothesis, hydrogen plus chlorine gives hydrochloric acid gas. Since atom is having independent existence, so n atoms of hydrogen, n atoms of chlorine will give us 2n compound atoms. He gave a new name to it, 2n compounds atoms of hydrochloric acid gas. Means 1 atom of hydrogen, 1 atom of chlorine will give us 2 compound atoms of hydrochloric acid gas, and half atom of hydrogen will combine with half atom of chlorine to give us 1 compound atom of hydrochloric acid gas. But, my dear friends, half atom cannot exist according to the Dalton's atomic theory. And now we can say that this theory, the Berzelius hypothesis, conflicts completely the Dalton's atomic theory, right? Now then came Avogadro. Avogadro said that the smallest particle of the element that can take part in a chemical reaction will be atom, and the smallest particle which can have its own existence, independent existence, will be a molecule. It means that he wanted to say that if hydrogen is reacting to chlorine, then H2 will have the independent existence, but H2 will not react with Cl2. H will react with Cl. Atom will react with atom, and molecule will have its independent existence. He applied the same thing on the same type of reaction, and his statement was the equal volume of all the gases under the similar temperature pressure conditions will have the same number of molecule. Berzelius said same number of atoms. Avogadro said it is same number of molecules. So, applying Avogadro laws on the reaction between hydrogen and chlorine. So, hydrogen plus chlorine gives hydrochloric gas. Earlier we did 1 volume of hydrogen and 1 volume of chlorine will give us 2 volume of hydrochloric acid gas. N molecules of hydrogen and N molecule of chlorine will give us 2N molecule of hydrochloric acid gas. It means that the same reaction, 1 molecule of hydrogen plus 1 molecule of chlorine will give us 2 molecules of hydrochloric acid gas. Half molecule of hydrogen, which is possible, half molecule of hydrogen is hydrogen atom, half molecule of chlorine is chlorine atom, and 1 molecule of hydrochloric acid. Therefore, Avogadro's law does not conflict the Dalton's atomic theory. It means that what Avogadro wanted to say, that the molecule will have its individual independent existence. H2 and Cl2 will exist, but H2 and Cl2 will not go in the reaction. H atom and Cl atom will react with each other. So that was Avogadros Law. Now, our next lecture will be on mole concept. So, there are some concepts which has to be brushed up that you have done in class 9th, like atomic mass, molecular mass. Those has to be done before mole concept. Let's study those, let's understand again in a better way. Now these things you have done in class 9th, like atomic mass. The atomic mass of an element may be defined as the average relative mass of the atom as compared to the mass of carbon 12, right? Means all the masses of the atoms or different elements are relative to carbon, and whenever you want to find the atomic mass of a particular element, that will be mass of the particular element whole divided by 1 by 12 multiplied by the mass of an atom of carbon, right? But if in case we have isotopes, in the case of isotopes we find the average atomic mass. For example, chlorine 35 and chlorine 37, their abundance in the nature is 3:1. Therefore, the atomic mass of the chlorine will be equal to 35 into 3, 35 into 3 plus 37 into 1 whole divided by 4. It is just a simple mean I am taking, and after taking the mean I am getting 35.5 AMU. So that's how we find the average atomic mass when there are isotopes, right? Now molecular mass. Molecular mass is sum of the atomic mass of the atoms present in the particular molecule. So molecular mass of a substance can be obtained by the atomic masses of all the atoms present in that substance. For example, if we have ammonia, in the case of ammonia, the formula is NH3. Molecular mass will be atomic mass of the nitrogen, because one nitrogen is there, and 3 into atomic mass of the hydrogen. Now what's the atomic mass of the nitrogen? It is equal to 14, and atomic mass of hydrogen is equal to 1. So it will be 14 plus 3 into 1, that is 17 AMU, right? Next is formula mass. Formula mass we use for the ionic compounds. Suppose NaCl. So for example, if we take NaCl, the formula mass of NaCl will be atomic mass of sodium plus atomic mass of chlorine. Atomic mass of sodium is 23 and chlorine is 35.5, and that comes out to be 58.5 AMU. So a special name is given to ionic compounds, that is formula mass unit, because the covalent compounds can exist as a molecule. Ionic compounds form a lattice. So we will not call it molecular mass. We will call it formula unit mass, right? The next is gram atomic mass. Now we know what is atomic mass, but if same thing is expressed in gram, that is called gram atomic mass, and numerically that is equal to atomic mass. For example, atomic mass of magnesium is 24 AMU. Therefore, gram atomic mass of magnesium will be 24 gram. Gram molecular mass. Now same thing we will apply, which we applied from gram atomic mass. Molecular mass we always find out in AMU. Gram molecular mass will have the same numerical value. It will have the same numerical value. It will be numerically equal to its molecular mass, but that will be mass in grams. For example, if we take ammonia, we just found the molecular mass of ammonia is 17 AMU. The gram molecular mass of ammonia will be equal to 17 gram. So these were the things I wanted to explain you before starting the mole concept. I hope you understood everything very well. So our next lecture is on mole concept, and that is very, very important as per the aspect of your board examinations and competitive examinations. So, till then, goodbye.